Hi, I'm going to talk today about the definition of the focal length. So we're going to be dealing with curved mirrors, and whenever you have a curved mirror, that mirror has a specific focal length. It is a property of the mirror, just like steel has a certain density. Doesn't matter what you do with the steel, it always has that density. Well, with a curved mirror, that mirror has a certain focal length no matter what you do with it. Doesn't matter if it's held here or here or here or here, it's got a certain focal length. And that focal length is related to the curvature of the mirror. So if we think of a curved mirror as being something like part of a circle, then if I were to kind of keep this circle going all the way around, the center of the circle would be right here. It turns out that the focal length is exactly halfway between the center curvature and the mirror. So we can figure out what the focal length is if we know the center of curvature. So the center curvature is double the focal length, or if you want it the other way, the focal length is half of the center of curvature. So if we had a curved mirror and the radius, because that center curvature is really the radius, if the radius was 10 centimeters, we would know that that mirror had a focal length of 5 centimeters. So what is this focal length? There are two definitions for a focal length. The first definition involves parallel light rays coming into the mirror. Suppose we have these 5 parallel rays of light all hitting the curved mirror. And this curved mirror has a center curvature about right here, which means that its focal is going to be right around here. And we know that that's the focal by saying if these parallel rays of light come in, they should all merge, combine right at that focal point. So this right here, if I think of this as a tiny little bit of flat mirror, then the light ray comes in and it's going to bounce off equal angles. So the angle it came in at and the angle it goes out at are going to be the same. So it's going to go off like that. And then the second one is, again, if I treat this as a little bit of a flat mirror, okay, so there's a perpendicular, so yeah, this is going to go something like that. This one, well, it's going to bend down just a little bit. And the same thing is going to be true for this ray and for this ray. So the first definition of a focal point, and I use focal point and focal length kind of interchangeably. The first definition for a focal length or focal point is parallel rays of light coming in all meet at the focal point. They're all focused down to this point. So that's the easy definition. That's the one that's kind of easier to see. The other definition of the focal is if we put a light source at the focal. Boy, this curvature didn't really work out very well. I even used a compass for it. There, something like that. So here's my center curvature. Here's my focal. If we put a light source at the focal point, so I'm going to put a little mag light or something right here. Then the light rays that leave the light hit the mirror are all those rays that leave the light, go to the mirror, hit the mirror, bounce off. Those rays will all come out parallel. So it doesn't matter what direction the light rays come at, all of these light rays should leave the mirror, parallel. So here we've got something like that. Okay, yeah, that's not too bad, something like that. Yep. That's almost perpendicular. Yep, there we go. And there, so it's going to bounce off. Yeah, so if I take each of these individually as a tiny bit of flat mirror, then with a light source at the focal point, all of the rays that leave the light source and hit the mirror are all going to come out parallel. Because these light rays here, it doesn't matter which way the light goes. If it's coming in or if it's going out that way, they're going to behave the same when they hit the mirror because, well, I don't care if it comes in this way, it's going to bounce out at that angle, or if it comes in this way, it's going to bounce out at that angle. So the two definitions for focal length: parallel rays of light coming in all meet at the focal point. And the second, an object placed at the focal point, all the rays that leave the mirror leave parallel to each other. And with the numbers, the focus is half of the center of curvature, or the center curvature of the mirror, how round it is double your focal length. So that's a real quick introduction to focal length.